Section 4.3 Homework, Point 17. The following data represent the number of calories per serving and the number of grams of sugar per serving for a random sample of high-fiber cereals. So here's my question here. Okay, the first question says, the scatter diagram of the data is shown over here on the right. And what type of relation appears to exist between calories and the sugar content? So when we look at the scatter plot, okay, it does not seem to be a strong linear relationship there. Okay, and there isn't a very strong nonlinear relationship. So there appears to be little or no relationship between calories and sugar content. Okay, the next question, part B, it says the correlation we want to be able to determine the correlation coefficient between calories and sugar content. So let's go ahead and open this data up into StatCrunch. So we're going to open up the data in StatCrunch. So we have calories in the first column, sugar in the second column. What we can do is we can go ahead and go to Summary Stats, and then select Correlation. Make sure that we select both of these. Select Compute. We want to round this to 3 decimal places. So we get 0.084. So let's go ahead and put that in there, 0.084. And therefore there is our correlation coefficient. Okay, now we need to determine the critical value for the correlation coefficient. Well, in order to do that, we need to look at the amount of sample size. So this is 1 ordered pair, 2, 3, 4, and then 5. So we're going to open up the critical values. So if we look at where n is equal to 5, what is the critical value? Well, the critical value is 0.878. So 0.878 is the critical value. Check our answer, and there is our result. Okay, now it's saying, is there a linear relation between calories and sugar content? Well, recall that if we take the absolute value of the following, so let's go ahead and put this question in there into our data sheet. Okay, and recall the following. So the correlation coefficient, which is R, the absolute value, okay, if it is greater than the critical value, then that means there is a linear relationship. Okay, otherwise there isn't. So the absolute value of 0.084, okay, is that greater than 0.878? Well, we're going to say that it's what? It's not greater than. And if it's not, then we need to determine from our results, okay, what does this tell us? So since the absolute value of the correlation coefficient is less than the critical value, there is not a linear relation between calories and sugar content. Okay, so there's not, so therefore that's going to be our answer. Okay, now we're going to look at the next question. It says, suppose that we add another cereal which has 50 calories and 3 grams of sugar per serving to the data set, and then redraw the scatter diagram of the data with this cereal included. So what we're going to do is we're going to go in here, and then we're going to open up this in StatCrunch. So we're going to put in the point 50 calories. So down here, we're going to add 50, and then here we're going to put in 3 grams of sugar. And now what we're going to do is we're going to create a scatter plot. So let's create a scatter plot where X is the calories, Y is the sugar. We want to make sure the points are highlighted, and then we also want to make sure that there's horizontal and vertical lines for us to clearly match our result. So there is our scatter plot. Well, down here you will see that the point is 50 and then 3. So down here it doesn't match that one. Okay, but let's take a look here. Okay, so there's 50 and it's on the 0 axis. This says 50 and that is 3. And the other points here. So it's between B and C. And if we look at B and C, you can see that it has 50 and then 3 and then 50 and 3 here. And look at the x-axis. The x-axis should represent the what? Calories. And the y-axis should be sugar. So therefore, we're going to select C. Okay, next question, it says now recompute the correlation coefficient. So now we're going to go back and repeat that process with the added point. We're going to go to stat, and then we're going to select summary stats, and then go to correlation, and make sure that we select both calories and sugar. Select compute, and now the correlation, round into 3 decimal places. Well, that 8 needs to round that 4 up, so it's going to be 0.835. 0.835 now is the new correlation coefficient. Okay, and then determine the critical value for the correlation coefficient. Well, now the critical value is now going to be based on 6 ordered pairs. So click on the icon, and then this is 6, and now we're going to see that the critical value is 0.811. So let's go ahead and put that in there, 0.811, and there is our critical value. Okay, now the question is going to ask us like we did before. So let's make sure that we have this information down here. Okay, and again, this is the new one, and they want us to know whether there is a linear relationship between these two. So for the second part of this question, okay, just like we did before, we're going to take the absolute value of the correlation coefficient, and we want to determine if it's going to be greater than 0.811. Well, if we look here, the absolute value gives us 0.835, and it is greater than 0.811. And therefore, we're going to say that there is a linear relationship. So, answering this question, since the absolute value of the linear correlation is greater than the critical value, there is not. That's not true. There is. So we're going to look for where it says it's greater than the critical value, and there is a linear relation between the calories. So we're going to select C, and there is our result. Okay, now it says, is the new point an influential observation? Now, what that means is, it says, since the variables appear to be linear related in both cases, there is not evidence to support that. Well, it wasn't linear related for the first one. It says, since the variables now appear to not be linear related when they did before, that's not true. It says, since the variables appear to not be linear related in both cases, that's not true. It says, since the variables now appear to be linear related, which is true, when they did not before, which is true, then there is evidence to support that the new point is influential. So we're going to say D, and there is our result. Okay, now it says, why is it necessary to show a scatter diagram with the correlation coefficient when claiming that a linear relation exists between two variables? Okay, it says influential observations can give insight into values of data outside the range of the rest of the sample. If these observations are excluded, the data may appear linear when they are only linear for a specific range. It says influential observations can cause the correlation coefficient to decrease substantially, masking other trends in the data. If these observations are excluded, the true trend of the data may be more apparent. It says influential observations can cause the correlation coefficient to increase substantially, thereby increasing the apparent strength of the linear relation between two variables. If these observations are excluded, the data may appear more scattered than they are. So on the next screen, I've opened up this question here, and you can see that all 3 of them are the results, because all of the above can show if a claim that a linear relation exists between those two variables.